Hi. So in this video, we'll start with a couple of problems on definite integrals, and we'll continue with this course. So here we are talking about I1 is equal to this particular integral, and I2 is this. And the question that is being asked, the first question is limit x tends to 0, I1 is equal to 1. This is given to us. We have to find sum of all the values of lambda. All the values of lambda. So limit as x tends to 0 of this integral is given to us, right? Now, let's try to think about this integral carefully. So if you notice, there is integral over the variable t, right? T square dt by x minus sine x. X minus sine x is not being integrated because x is a different variable from t. So all you have to do is you have to take out the x minus sine x because it's a constant as far as the integration is concerned. The integration is about t variable, x is a constant. So I take it out and I write it like this: x minus sine x integral of 0 to x t square by root over lambda square plus 2 lambda t dt, right? Okay, now I have to take limit of x tends to 0 of I1, and that is given to be equal to 1, right? Therefore, this is basically limit of x tends to 0 integral 0 to x t square by root over lambda square plus 2 lambda t divided by x minus sine x. And notice that this is in the 0 by 0 form, right? So I can do L'Hospitals here and I can differentiate the top and the bottom as well. So what I get is x square by root over lambda square plus 2 lambda x, right, into 1 divided by 1 minus cos x, right? This is the thing, and now I have to take limit x tends to 0 here, right? Okay, so how do we take this limit? For this, what we will do is we will write this as limit x tends to 0 x square by 1 minus cos x multiplied by 1 by root over lambda square plus 2 lambda x. So this limit is doable. This is a standard limit because 1 minus cos x is 2 sine square x by 2, and you have x square here. So divide by 4 and multiply by 4. So this limit will come out to be, this part will be 1 and the limit will be 2. So the limit will be basically 2 by root over lambda square, right? Plus 2 lambda x, which will be 0. So we have 2 by mod lambda is equal to 1 because the limit is given to be 1. So I have mod of lambda is coming out to be 2, right? So lambda can be plus or minus 2. So the sum of possible values of lambda will be 0 because plus 2 and minus 2 are the two values of lambda, right? Now, the other part of the question is saying if lambda is equal to 1, next question, I will do it on the next screen. It says if lambda is equal to 1, then find the value of limit x tends to 0, I1 plus 6 times I2, right? Now, here lambda is 1. That means the integral I1 looks like this: 0 to x t square dt by x minus sine x root over 1 plus 2t, 1 plus 2t, right? And I2 basically, correct. So let's find out what is the limit x tends to 0 here. Limit x tends to 0 here, right? Because anyway, we have to find that limit x tends to 0 I1. So that will be equal to x minus sine x outside again and integral 0 to x t square dt by root over 1 plus 2t. So again, it is L'Hopital's rule. So differentiating, we get x square by root over 1 plus 2x multiplied by x minus sine x. So this limit will come out to be, this will be basically, no, it will be differentiation. So it becomes 1 minus cos x here, just like last time. And that can be written as 2 sine square x by 2, x square by 2 sine square x by 2, root over 1 plus 2x. And in the same manner as before, we divide by 4, multiply by 4, and the limit will come out to be 2, right? Same as before. So this I1, this part is equal to 2. We have to find limit of x tends to 0 for 0 to x square e power t minus 1 minus t by x power 6, right? dt. So this can be again written as 0 to x square e power t minus 1 minus t divided by x power 6, right? And I have to take this limit as x tends to 0. So obviously, again, this is in L'Hopital's form because this part is tending to 0 and this part is also tending to 0. So what I get after differentiating is e power x square minus 1 minus x square divided by 6x power 5, limit of x tends to 0, right? Now, this becomes 6x power 5. Actually, there is a 2x also. When I differentiate the top, I put the upper limit in this and then differentiate the upper limit, right? So 2x cancels here and this becomes 3x power 4, right? So what I have to get is 1 by 3 limit of x tends to 0, e power x minus e power x square minus 1 minus x square by x power 4, right? So here we can utilize Taylor series here. Let me just write down what you will get. So if you do the Taylor series expansion for e power x, what you get here is this particular expression. E power x square would be 1 plus x square powers whole square by 2 factorial plus x square power whole cube by 3 factorial and so on, right? So this is 1 plus x square plus x power 4 by 2 plus x power 6 by 6 and so on, right? So you have e power x square minus 1 minus x square will be simply x power 4 by 2 plus x power 6 by 6 and so on. And divided by x power 4, the limit will tend to be half, right? So this limit comes out to be half. So you get 1 by 3 into 1 by 2, which is 1 by 6. So 6i2 is basically going to be equal to 1. So the answer here is 3. 2 plus 1, 3, right? So that was this question. We utilized our knowledge that we can differentiate under the integral sign. And we also found out the two integrals. We took out the variable x minus sin x and it became L'Hopital's form. So that was the main idea here. Let's look at question 52. It says let f be a cubic polynomial where f of x plus f of minus x is equal to 0 for all x belongs to real. Okay. We also have limit of h tends to 1 by root 3 f dash h minus 2 by h minus 1 by root 3 is equal to 4 root 3, right? Now, the first thing is, if phi of x is equal to integral of 1 to x e power t f of x plus 1 minus t dt plus 5 by 4, then find phi dash 1. Okay. So let's think about this f of x polynomial because we have f of x in this integral, right? So clearly this statement means f of x is equal to minus of f of minus x, means f of x is odd. f of x is odd and it is a cubic, that means f of x must be like this: ax cube plus bx, right? This is a cubic polynomial which is an odd function. If I had an x square term, if I had an x square term, then it will no longer be odd function, right? And if I had a constant term also, it will no longer be odd, right? Because when I put f of minus x in this one, it becomes negative of f of x. But in this one, it will not become negative of f of x. You can confirm this for yourself. Any odd cubic has to have this form, right? Great. So now we know that limit of h tends to 1 by root 3 f dash h minus 2 by h minus 1 by root 3 is equal to 4 root 3. So we will use that condition because we can see f dash h will be equal to 3ah square plus b, right? So 3ah square plus b minus 3ah square plus b minus 2 divided by h minus 1 by root 3, limit of h tends to 1 by root 3, right? This is what it is. Now this portion disappears, this portion goes to 0. So this portion must also go to 0 if you have to have a finite limit. If this doesn't go to 0, you have something non-zero divided by 0, which will be infinite, right? So first thing we know is 3a 1 by 3 plus b minus 2 is equal to 0, right? So that means a plus b is equal to 2, right? That is the first thing that we get. Now, if it is 0 by 0, you can do L'Hospitals and you can differentiate it once more. So it will be 6ah by 1. That is the limit. Limit h tends to 1 by root 3. So you'll get, therefore, 6a into 1 by root 3 is equal to 4 root 3. So therefore, 6a is equal to 4 into 3, 12. So a is equal to 2. So b is equal to 0, right? If a is equal to 2, then b is equal to 0. And your fx has come. Fx has become, fx is simply 2x cubed, right? So we have found out the value of the function definition from just one condition here, and the fact that f of x was an odd cubic, right? So now the question becomes fairly easy. If we want to write down phi of x now, right? So phi of x was equal to integral of 1 to x e power t f of x plus 1 minus t dt, right? So we can write this as 1 to x by applying the property f of integral a to b f of x is equal to integral a to b f of a plus b minus x. You can write this as e power 1 plus x minus t and f of x plus 1 minus 1 minus x plus t dt, right? So phi of x becomes equal to okay, phi of x becomes equal to basically 1 to x e power 1 plus x minus t multiplied by this cancels, you get f of t dt, right? Okay, so this can be written as e power 1 plus x can come out because t is the integration. You don't have an integration over x. So it is 1 to x e power minus t f of t dt, right? Correct. Now, clearly, your phi dash x will be equal to e power x plus 1 into differentiation of this will be e power minus x f of x plus e power x plus 1 is the differentiation of e power x plus 1 into 1 to x e power minus t f of t dt. Right? So this is me differentiating phi of x, and pi dash 1, let's see, pi dash 1 will become e power 2 e power minus 1 f of 1 plus e power 2, and integral 1 to 1 is 0. So you get e into f of 1 is phi dash 1, right? So f of 1 is actually e into 2 into 1 cube. So this is 2e. So your phi dash 1 has come out to be 2e, right? Correct. So that is what we wanted to find actually. So this is done. Notice what we did here. We had this function. We separated the x parts. We took out the x parts. First, we did the property a plus b minus x. Then we took out the x parts. And then because we wanted to find differentiation phi dash x, we just differentiated by product rule here. And after that, the question is done because we already know f of x is equal to 2x cubed, right? So this should be interesting. Let's look at another question, another polynomial question, question 53. So here we have let p of x be a polynomial satisfying satisfying the equation p of x minus p dash x is equal to x square plus 2x plus 1. Okay. Also f of x is equal to p of x by 10 whole to the power 1 by sine of 3 sine 4x minus 4, right? This is only when x is not equal to 1, and 1 by e to the power k square minus 9k plus 40 when x is equal to 1, right? We have f of x defined like this. The question is, if f of x is continuous at x is equal to 1, then what is k? Correct. After that, there is another question, which is the integral of 1 by px. We'll go in a step-by-step manner. So let's think about f of x. But in order to think about the continuity of f of x, we have to worry about your polynomial p of x, right? So let's think about this equation. This equation is true for all x. So let's say p of x has degree n. The first thing to figure out is what degree polynomial do we have. So p of x is degree n and p dash x is degree n minus 1. So LHS has degree n, because when you add or subtract two polynomials, the higher degree is what remains, right? And RHS is degree 2. Degree 2 is RHS, right? So therefore n must be equal to 2, right? Otherwise this relation will never be equal, right? N is equal to 2, then we know that px can be written as ax square plus bx plus c, a quadratic polynomial in general, right? So p dash x will become 2ax plus b. So what we have is p of x minus p dash x is always equal to x square plus 2x plus 1. So what we get here is ax square plus b minus 2a x plus c minus b is equal to x square plus 2x plus 1. So that implies that a is equal to 1, obviously, and b minus 2 is equal to 2. So b is equal to 4, and c minus b is equal to 1. Therefore, c is equal to b plus 1, which is 5. So I get my polynomial px immediately. Px is equal to x square plus 4x plus 5, right? This is my polynomial px. So now I have to think about the continuity of p of f of x at this point, right? So let's think about that. So at x is equal to 1, if the function is continuous, right? If the function is continuous at x is equal to 1, we need to have limit as x tends to 1. X tends to 1, f of x should be equal to the value of f of 1, right? So let's try to find out this limit then. So we have f of x tends to p of x by 10, p of x by 10, and you have on top 1 by sine of 3 times sine of 4x minus 4, right? Now p of x was x square plus 4x plus 5. So this is tending to actually 10, right? 1 plus 4 plus 5. This is tending to 10. So this is tending to 1, and this is tending to infinity. So it is of the form of e power infinity. So what we have to do is 1 power infinity form. So what we have to do is we can write it as 1 plus px by 10 minus 1 whole to the power 1 by sine thing, right? So this part now tends to 0, right? So the limit will be e power limit x tends to 1, and this will be px by 10 minus 1 multiplied by 1 by the sine function, right? This is the limit as this x tends to 1 here, right? So let's do that calculation. X square plus 4x plus 5 by 10 minus 1 multiplied by 1 by sine 3 times sine 4x minus 4, and we have limit of x tends to 1. So this becomes x square plus 4x minus 5 by 10 multiplied by 1 by sine 3 times sine 4x minus 4, right? Okay. So this thing actually tends to 0. So we can use L'Hospitals now in this limit because it is 0 by 0, right? So I will just use L'Hospitals here, and let's see what comes from that. If you use L'Hospitals rule here, you get 2x plus 4 on top divided by 10, and you get cos of 3 times sine of 4x minus 4 multiplied by 3 cos 4x minus 4 multiplied by 4, right? So this is what we are getting. And notice that x tends to 1, now it is not 0 by 0. So you'll get 2 plus 4, 6 by 40 cos of 0, which is 1, and 3 cos of 0, which is also 1. So it is going to be 2 by 40. So 1 by 20, right? 1 by 20 is coming out to be my limit. Therefore, f of 1, the value of f of 1 should also be 1 by 20, right? Then only the function is continuous and the limiting value is equal to the function value. And therefore, 1 by e power k square, e power k square minus 9k plus 40, this should be equal to 20, right? Okay. Actually, this was the limit, and the value of the function was e powered 1 by 20, right? The limit was totally e power 1 by 20. So let's write that here correctly. We have e power 1 by 20. Correct. So now we should get, okay, I've written this correctly, but I've written this part incorrectly. This is k square minus 9k plus 40, right? Minus 9k plus 40. Correct. So we'll have an equation connecting this and this, right? So we should have this equal to this, and you can solve that to find k. Find k using this. So I'm a little unsure about what the expression of this function is. I feel like there is some mistake in the source from which I'm checking it out. But in general, the question is solved. All you had to do was really find the limit, right? It was not a very difficult question. It was just about finding the limit. Let's move on. Question number 54. In this question, we look at g of r to r is a differentiable function, which satisfies this condition. G of x is equal to 1 plus integral 0 to x g of t dt, and g dash 0 is equal to 1. Now you have to find out the value of g of ln 10 plus g dash ln 10 plus g double dash ln 10. You have to find out this value. So let's find out first g dash x. G dash x will be simply g of x, right? G dash x is equal to g of x. Now g dash 0 is therefore g of 0, right? And now we have g dash 0 is 1. So g of 0 is actually 1, right? We get this value, correct? Now this can be integrated here. G dash x by g of x is equal to 1. Integrating, you get ln g of x is equal to x plus c. So g of x should be equal to e power x plus c. Now putting the value of 0 here, you get e power c is equal to 1. So c is equal to basically log, you take c log e, so it is log 1, 0, right? C is 0. So therefore, we have g of x is coming as e power x, correct? We found the function here. This was simply one differentiation and then solving this differential equation, which was by simple integration. Now you do g of ln 10 is equal to e power ln 10, which is 10, and g dash ln 10 will also be e power ln 10, which is 10, and g double dash ln 10 will also be equal to 10. So the answer here will be 30, right? Okay. Now let's move on to the next one. Correct. So in this question, we look at a specific type of question where there are multiple variables. And let's see how we analyze that. So let f be a real valued continuous function, real valued continuous function such that it satisfies f of x is equal to x square plus minus 1 to 1 x plus y f of y dy. This is the equation where x and y are independent, right? Now what we have to find out is what is f of x. You have to find out the function f of x, okay? So let's see how we handle this. Here you have to realize that this integral is over y, right? It is not over x. So I can write this fx as x square plus, it is minus 1 to 1 x times f of y dy plus minus 1 to 1 y times f of y dy, right? So you can realize that f of x is actually x square plus x common minus 1 to 1 f of y dy, because x is a constant here, plus some minus 1 to 1 by f of y dy, right? So notice that this will be a pure number because this is area under f curve and this is also a number. So this is basically you're getting f of x looks somewhat like this, x square plus ax plus b, where a is equal to minus 1 to 1 f of y dy and b is equal to minus 1 to 1 y f of y dy, right? Now we will actually put this expression for f into these two equations to get a and b, right? So how do we do that? Since fx is coming like a quadratic function, we can say A is equal to integral of -1 to 1 f of y dy, right? So A is equal to -1 to 1 f of y is y square plus ay plus b dy. So this becomes y cube by 3 plus ay square by 2 plus by from -1 to 1. So A is equal to, you get 1 by 3 plus a by 2 plus b minus -1 by 3 minus a by 2 minus b into -1, right? A by 2 gets cancelled and you have plus 1 by 3. So 2 by 3 plus b plus b. So plus 2b is equal to a. So the first equation you get is a minus 2b is equal to 2 by 3, right? We need another equation. We need another equation to solve it really. So we'll use the second condition here, right? So let's see what we get there. So we have b is equal to -1 to 1 y f of y dy, which is equal to -1 to 1 y f of y is a y square plus by ay square plus by plus y cube, right? Dy. And doing this integral, now all the odd functions, this function and this function will disappear, right? Because -1 to 1 odd function integral is equal to 0. So what we have is -1 to 1 ay square dy, which will be equal to b is equal to a y cube by 3 from -1 to 1, which will be a by 3 minus a by 3, so 2a by 3. So we get therefore b is equal to 2a by 3, and the previous equation was a minus 2b is equal to 2 by 3, right? So we can say a minus 2 times 2a by 3, so 4a by 3 is equal to 2 by 3. So minus a by 3 is 2 by 3, therefore a is equal to -2, right? We get a is equal to -2, and therefore b is equal to 2 times a by 3, so -4 by 3, and you get your function f of x is coming out to be x square minus 2x minus 4 by 3, right? So that is what we wanted to find here. We have found our function f of x, right? Okay. So remember this trick where there are two variables, then what you do is separate out the x part and the y part and think of it as a function in x. Because the y part would have been a number, like this quantity would be area under this curve, right? So this will be a pure number. So just think of it as a function in x, and then you will be able to basically solve the problem. In the next few videos, what I will do is consider some slightly harder but very typical integrals and show you some techniques that you might not have seen elsewhere. We are coming towards the end of the course. However, like just stay tuned for the next couple of videos. It will be interesting because you might not have seen those techniques before. So it might be useful as you prepare for your exams. So keep watching and see you in the next video.